Okay, so today we're looking at the gradient of a straight line. So our learning intention is to gain the knowledge in how to calculate the gradient of a straight line. We'll be successful if we can identify positive and negative gradients. Calculate the gradient either using the formula, using the fact that tan theta is also equal to the gradient, or using the gradient intercept form of an equation. Okay, so let's do some examples. All right. We want to calculate the gradient between these 2 points. I've got a point here at negative 1.1, so negative 1, 1, and a point here at 2, 1. All right. Now, if I was to connect these 2 points, if I was to connect the 2 points, we would get a line. Yeah. And it's going up to the right, so this is what we call a positive gradient. Yeah, so if it's going up, it's positive. If it's going down to the left, to the right, it's negative. All right, so I've got 2 points, and what I'm going to do is I'm actually going to calculate the gradient using the formula. So m, being the gradient, is y2 value minus y1 value minus x2 value minus xy value. Yeah, it comes from, you might know it as the rise over the run. So the change in the rise divided by the change in the run. Okay, so it doesn't matter which one you consider to be your first point or your second point. So let's just say, for the sake of it, I'll say this is my x1, y1, and this would be my x2, y2. Okay, so y2 is 1. I'm minusing it from y1, so 1 minus 1. Oh, sorry, this should be negative 1. Negative 1, negative 1, sorry. Yeah. Negative 1. Okay, my x2 is 2, and my x1 is negative 1. All right, cleaning this up, I get 1 subtracted from negative 1 becomes 2. 2 minus 1 is 3, so I have a gradient of 2 over 3. So if I had a line, what I would do is I would count out how many, from this step from this point to this point, how many steps would I go up? I go 1, 2, and I go across 3 spots. 1, 2, 3. So my gradient, the rise of 2, 1, 2, of a run of 3, 1, 2, 3. And there's my gradient, and it's a positive direction. Okay, so that's how to calculate the gradient using the formula. The formula is not in our formula sheet, so it's something that you have to remember. Okay, rise over run. All right, we want to find the gradient of the following. Okay, one of the things is something like this is in the gradient intercept form. The gradient intercept form is y equals mx plus c, where m is your gradient and c is your y-intercept. So here, my gradient, my m value, is negative 3. So therefore, the gradient of y equals negative 3x plus 4 is negative 3. And if I was to sketch it, well, the sketch would look like this. So my y-intercept is at 4. 1, 2, 3. Not to scale, right? And what it's saying is I'm going to have a gradient of a rise of negative 3 units. 1, 2, 3. And a run, this can be expressed as negative 3 over 1, of a run of 1. Yep. So I have a gradient, start my y-intercept, a gradient of negative 3, 1, 2, 3, over a run of 1. So this point would be 1, 1, and this point is 0, 4. Yep. And that is my line. That's my line. Okay. Here I have an equation in its general form. Okay, I can rearrange this so that it looks like the gradient intercept form. So bringing that y across, I get 2x plus 4. So here my m value equals 2. So the gradient is 2. Okay. Once again, we could sketch it. It's not that difficult. We're going to start at 4. Again, your y-intercept. 1, 2, 3, 4. And here I have a positive gradient, so I'm going up 2, 1, 2, and across by 1. So this point would be 1, 6, and this would be 0, 4. Join the dots. And we get a positive gradient, and here we have a negative gradient. Okay. So once again, this is an equation. It's not, it's a fraction. What we can do is we can multiply both sides by 5, giving us 3x minus y equals 10. I can rearrange it. 3x minus 10 equals y. So the gradient, which is the coefficient of x, gradient is 3. Yeah. So it's positive, so it's going up to the right direction. Okay. All right. So please remember this formula: y equals the y2 minus y1 over x2 minus x1. You would have seen that in year 9 or year 10. Yeah, that's how to calculate the gradient. Yeah. And this is obviously, if you got the equation, you can rewrite it into gradient intercept form, and it's the coefficient of x. Okay. Now, another way of doing it is using trigonometry, or understand trigonometry. Okay. What I'm going to do is I'm just going to draw my Cartesian plane, something like that. And here I'm going to draw, sorry, I'll just screw it out. All right, I'm going to draw a line, right? And I'm going to say that this angle here is 45 degrees. Okay, I want to calculate that gradient. Now, I can calculate that gradient using the understanding that the tan of 45 is the y value, this height, the rise, divided by the run. So really the formula is m equals tan theta, all right? So if tan theta equals 45, I should be able to just plug that into my calculator and figure it out. So I'm just going to make sure I'm in degrees mode. So tan 45 is 1. All right. So my gradient is 1. So something like that, an equation like that would be y equals x. Okay. All right. Looking at this one, okay, I'm just going to quickly, just a real rough sketch. 27 degrees and 30 minutes is somewhere around about here. Doesn't matter. Don't need to be accurate for this one. I'm going to use the formula that m equals tan theta. Yeah. The theta in this situation is going to be 27 degrees and 30 minutes. Plug that into my calculator. Tan 27 degrees and 30 minutes. Yep. Close the brackets. And I get 0.52. I'm going to go to 1, 3 decimal places. Yeah. Okay. So something like that would be y equals 0.521x plus or minus something. Okay. Right. This one, let's talk about this one. We've now got this being 120 degrees. All right. So using that formula, m equals tan of 100 or tan theta tan in this situation is 120 degrees. All right. So we've got tan 120 degrees, and we get negative 1.732 3dp. Okay. And you can tell if we were to continue this line, right, like that, we would definitely get a negative gradient. Okay. And so in this situation, yes, our angle is definitely, our gradient is negative, so we should expect a negative number. All right. If you do know what exact triangles are, this is basically going to be the exact triangle 60. So 60, looking at our exact triangles, which is on our formula sheet. So tan of 60 is opposite over adjacent. So it's going to be negative root 3, okay, as an exact value. All right, and if you plug in negative root 3 onto our calculator, right, we get the same number, right? So that's what it means. Okay, so using negative root 3 is our exact value. You can only do this kind of stuff if you know about the exact triangles in trigonometry. Okay, otherwise just happy to use this formula. Okay. Now we want to find the angle inclination of a line with the gradient of 2. So using our formula again, we get, or maybe just sketch it. So we've got some gradient and it's positive, so it's going up like that. All right. So using our formula, m equals tan theta. Here we've got 2. We want to figure out what theta is. So using trigonometry, theta is inverse tan 2, so you plug that into calculus. So we go shift tan 2, and then I get the degrees bubbles. So let's do it to the nearest minute. So this is 63 degrees and 26 minutes. Okay. What about m equals, so negative 5. So what's happening? I'm going down this way, right? Going down. So m equals tan theta. All right, if m was negative 5, tan theta, we're going to do inverse tan. So shift tan negative 5. All right. I'm getting this negative 78 degrees. So that's saying that part. So I'm going to ask you to think, what if we pressed, instead of negative 5, we went tan of 5. Okay. So what we're going to do is we're going to subtract this from 180, okay, to get our real angle, okay? So 180 minus answer. All right, so we get an angle of inclination of 101 and 19 minutes. And this is really the answer. So obviously be very careful when we have negative gradients, because we actually want this angle here, which is going to be obtuse. Yeah, the negative 78 made no sense. Whereas we got the 101, we need to take that solution from 180 to get that. All right. Now let's figure out this one. So m equals tan theta. M in this situation is 6.3, so it's a positive gradient. Theta equals inverse tan negative 1 of 6.3. We get 80 degrees and 59 minutes to the nearest minute. Okay. So that's how we can use trigonometry to find our gradient. Okay. So just a reminder, to be successful, we need to remember the formula, y equals m equals y2 minus y1 over x2 minus x1, or the right over run. Tan theta equals y over x, or m equals tan theta. and understand which one is the gradient intercept form. Okay, so good luck.